following program is brought to you by Copeland Corporation.
Hi, my name is Glenn Hannigan. I'd like to help you understand some of the common causes of compressor failures. When looking into this subject, you have to start with one very interesting fact. Industry records clearly show that replacement compressors, whether they are new or remanufactured, fail at a rate many times greater than compressors going into new systems. This clearly demonstrates that there is often a problem with the system itself. This problem has caused the original compressor to fail and will probably cause the replacement to fail as well. So how do you tell if your failure was caused by a system problem? The answer is inside the failed compressor. You have to open up the compressor and look for the various clues that can show you the true problem. Many failures end with a motor burnout, misleading some technicians into thinking that the root problem was electrical. This just isn't the case. Inspections show that the problem usually starts somewhere else and gets steadily worse until it causes the motor to fail. The blame goes to the motor. The true problem remains. There are 5 main causes of compressor failure: flooded starts, refrigerant floodback, slugging, overheating, and loss of oil. We're going to look at refrigerant floodback in this tape and learn what refrigerant floodback is, what causes it, and what we can do to prevent this problem. Let's watch.
Refrigerant floodback, commonly referred to as simply floodback, occurs when liquid refrigerant flows through the suction line into the compressor during the running cycle. Depending on compressor construction, this liquid refrigerant dilutes the oil on the cylinder walls or in the crankcase and causes the moving parts to wear, seize, or break. In air-cooled compressors such as this one, liquid can move very easily into the cylinders. The suction vapor enters through the suction service valve on the compressor body at the cylinder end. Small amounts of liquid refrigerant may be separated by a decrease in velocity in the vertical passageway, return to the crankcase through oil drain holes, and dilute the oil in the crankcase and cylinders. But the majority of the liquid will be carried by vapor velocity through the suction reed valves and into the cylinders. This liquid will wash the oil off the pistons and cylinder walls during the suction stroke. Even if the heat of compression vaporizes the liquid on the compression stroke, there will still be wearing and scoring of the pistons and cylinder walls. Larger quantities of liquid that cannot be vaporized or squeezed through the discharge reed valve causes a condition known as slugging. In a refrigerant-cooled compressor, the suction vapor enters at the motor end of the compressor, cooling the motor as it passes to the suction valves. Small amounts of liquid refrigerant carried back to the compressor by the vapor are boiled off by the motor heat, causing little harm. During a floodback condition, however, there is too much liquid refrigerant to boil off, and it separates in the motor housing, flowing to the crankcase through the oil check valve, where it will dilute the oil in the crankcase. The oil pump will then pump this refrigerant-rich oil to the rod and crankshaft bearings. The heat of friction will boil the refrigerant out of the oil, and there will not be enough volume of oil to reach the rods and bearings furthest from the oil pump. A pattern of wearing, overheating, seizing, and breaking of the running gear components starts at the bearing closest to the oil pump and worsens as it reaches the bearing surfaces furthest from the oil pump. With excessive wear in the motor end and center bearing, the end of the shaft may drop enough to cause rotor drag and result in a shorted or grounded motor. If a failed compressor is not examined for the wear pattern, the true cause of the motor burn may not be known. Floodback commonly occurs when you lose control of the liquid refrigerant being fed into the evaporator. This can be caused by such things as 1. Low evaporator loads or sudden changes in loads. 2. Refrigerant overcharges in a capillary tube system. Or malfunctioning or improperly adjusted thermostatic expansion valves. The first cause, low evaporator loading, may be the result of oversizing the equipment for the actual refrigeration load. It can also be caused when the evaporator cannot pick up heat adequately. Poor heat transfer is often caused externally by a variety of problems brought on by dirt or excessive frost and ice. Locate product to maximize air circulation and make sure you properly place return and supply ducts to prevent air recirculation. Maintain clean filters. Keep grills and air ducts open. Check evaporator fan blades for excessive dirt or motor failure. Oil logging in the evaporator can also lead to poor heat transfer. Proper installation and preventive maintenance, proper control settings, and adequate defrost will solve all of these problems. If you know the evaporators are loaded correctly, the next thing to check is for proper operation of the liquid control devices. On capillary tube systems, make sure that the system is charged correctly. On expansion valves, check for three things: correct superheat settings, correct size selection, and correct application. The first item, the superheat at the outlet of the evaporator, should be checked not only at full load conditions, but also at minimum load conditions, because floodback occurs most frequently during this time. At minimum load condition, the expansion valve often isn't able to respond quickly enough to prevent floodback. Follow the manufacturer's recommendation.